Welcome to this video where we're going to go over a non-homogeneous linear second order differential equation. Whew, okay, I'm ready to be done. Just kidding. But really, y double prime plus 5y prime plus 4y equals 2x plus 3. This is different from your homogeneous variety because it actually equals something over here. I'm going to do a video where I go over the rules a little bit more. So if you're looking for a more complex example, or you have a situation, a math problem that doesn't quite match this, then you can go here for a video where I'm going to at least attempt to do all possible um, variations on these differential equations because there's a lot of rules and technical stuff. But for right now, I am just for this video going to do this example and work out this problem. I'll explain a little bit along the way. How do I solve this? Well, I'm first going to I'm going to use a different color, and I'm going to just look at this part. This is the part where I can treat as non-homogeneous. And I'm going to do a quick diagnostic. I'm going to convert my y primes to r's. I'm going to say r squared plus 5r plus 4 equals 0. And I'm just going to find the factors of this. What multiplies to 4 and adds to 5? I'm going to say r plus 1 and r plus 4, which must equal r equals negative 1 and r equals negative 4. And I'm going to stick those roots into a equation and say y equals c1e to the negative x using a root plus c2e to the negative 4x. What do I do now? Well, I derived this for two reasons, and I'll go ahead and circle this. First reason is I wanted to get this equation because it will be part of my final equation. I'm going to add this to another solution, and that will be my final solution. Secondly, I wanted to know e to the negative x and e to the negative 4x, because if I have a term up here in this, say e to the negative 4x, I have to make some changes in order to get my proper solution. And I'll go through that in just a second. So I've got 2x plus 3. And what do I do now? I say I want to copy this same structure. I have a number being multiplied by x plus 3. So I'm going to say a number being multiplied by x plus another number. If this was something like 6e to the negative 5x, just making that number up, then I would say a e to the negative 5x. If this was trigonometry, there's a little bit more to trigonometry than this, but just for example's sake, if you don't know how to do trigonometry yet, if I had 5 sine of 3x, then I would say a sine of 3x. There's more to it than that, but I'll just leave it there for right now. You just want to copy that basic structure and keep your roots of negative 5x or 3x or whatever your inside function would be. So I have ax plus b. And if this happened to be ax plus b e to the negative 4x, then I can't have the same root on this solution and on this equation. It won't work. So I'm going to add bx e to the negative 4x. I have to do that if I have something that matches between these two. More on that in this video. But thankfully I don't have anything that matches in this problem. So I'm just working with ax plus b. So I'm going to say y equals ax plus b. Y, our function that we're solving for, is just a general function of the structure ax plus b. Now, if I know what this y is ax plus b, what is y prime? I'm going to take the derivative. I'm going to say y prime equals the derivative of this, a. And I'm going to say y double prime equals the derivative of my derivative, and that's going to be 0 because the derivative of any constant is 0. So now I have my y prime, and my y double prime. And I'm going to circle that just to separate this from everything else. And now I can take this equation, and I can say wherever I see a y, I'm going to plug in ax plus b. Wherever I see a y prime, I'm going to plug in a. And wherever I see a y double prime, I'm going to plug in 0. So copying this down, I'm going to say 0 equals y double prime, 5 y prime, which is a, 0 plus 5a plus 4, and my y is ax plus b, ax plus b, and then I'm going to say equals, and what does it equal? 2x plus 3. Perfect! Just perfect! So now I can simplify this as much as I can. I'm going to say 5a plus 4ax plus 4b, distributing the 4, equals 2x plus 3. Now I'm going to sit down and I'm going to say I want to combine like terms. And there's several ways to do this. For this example, I am going to say underline terms, and I'm going to say terms of x. So I'm going to say I want all my terms with no x to begin with. So I'm going to underline every term with no x. And then I'm just going to say I'm going to write an equation with just those numbers. 5a plus 4b equals 3. All I did was I took all the numbers and carried down the equal sign and just wrote those numbers down. Then I'm going to say, I hope my blue marker still works. It was kind of dry last time. I'm going to take all my x terms. Oh yeah, that doesn't work at all. Okay. So I'm going to take all my x terms. Maybe my red one will work. And I've got those ones. So I'm going to make another equation. I'll write this one in red. 4ax equals 2x. And if I had my x squareds, I would have some x squareds and x cubes and so on and so forth. I'd just copy that same pattern. So now I've got here two unknowns, a and b, and I have an unknown here, a, and I have two equations. That means I can solve a system of equations. So I'm going to do my system of equations, and this one looks really easy because I have one equation and one unknown. I'm sorry, this one looks really easy because I have one equation and one unknown. So I'm going to solve that one, and I'm going to say, first of all, divide out my x's. And so I'm going to have 4a equals 2. Divide by the 4, a equals 1/2. That was easy. And now that I know my a value, I'm going to put it up in here. And I'm going to say 5 times 1/2 plus 4b equals 3. Good. That means 4b equals 6 over 2 minus 5 over 2. And that means b equals 1/2 times 1/4, dividing by the 4. That equals 1/8. Well, I've got my a and b values. I've solved my system of equations. What am I going to do now? Well, I'm going to refer to my original y. In fact, I'll do this in green. Y equals ax plus b. And since I know my a value and I know my b value, I have just solved this equation. And so I'm going to say y equals a 1/2 x plus b 1/8. Bam! So what's my final solution? I'm going to take this solution and I'm going to take this solution and I'm going to add them together. So my y final, I'll write a little yf for final. Your professor probably is going to use different notation than me. C1e to the negative x plus C2e to the negative 4x. And then I'm going to say plus 1/2 x plus 1/8. And that is my final solution in a problem without initial conditions. If you have any questions, refer to this video where I cover a lot more situations and a lot more rules that will occur when you're trying to solve this. You can find that video here. Or post a problem to our Facebook page, and that's going to be facebook.com/jokoengineering. And please subscribe because this really helps me out. Otherwise, I will see you next time.